Thank you, and hi everyone. Thank you for joining us today for this session. I'm Dmitry Raidman. I'm the CTO and the co-founder of a company that's called Cybeats. Cybeats is a company that provides solutions for software supply chain security and SBOM management. And in addition, I'm also participating in the CISA Tiger team that defines what is AI SBOMs. And as part of this participation, I have another two partners who co-leading this with me, which are Helen Oakley from SAP and also Daniel from Manifest Cyber. So I'm going to talk today about what is AI SBOM, right? What kind of risks, what kind of, I would say, vulnerabilities, right, and attacks we can experience in this new emerging technology, and it's still emerging. I think we just in the infancy of it. And we will learn also why AI SBOMs are important and how they can help us to understand our landscape and prepare better for the future. So the year is 2030, 5 years from now. And there is this great company, it's called Acme Investment Portfolio Trading. And one beautiful day, the AI model makes overly aggressive and incorrect market recommendations to the customers. And that's resulting in $80 million loss. Well, doesn't sound fun, definitely. But the executives of the company, if I'm the AI security person, looking at me right now, together with the regulators and customers, and asking, hey, what have influenced the model? How can you explain that? How can you prove now that our AI models are operating properly and they were not modified or affected by an adversary? Well, if I can't answer this question, I don't have an AI problem. I have a different type of problem, which is governance, security, and compliance nightmare I'm going to experience. And that's exactly why we need these AI SBOMs, right? Because we need to know that on April 1st, 2030, 7 days before the attack, a sophisticated adversary exploited a vulnerability in AI model training pipeline of open source AI model, and he was able to replace or inject poison training data into one of the data sets, the training the model. Eventually, the Acme company pipeline picked it up, built it without any suspicion, and deployed to their production environment, resulting in these huge losses. And this is a really realistic scenario that really happened to one of the companies. If you Google it, I'm not going to mention it. It was in the housing market, that something that was buying houses. It wasn't a malicious attack there, right? It was probably an honest mistake of someone, but that caused a lot of losses based on the AI algorithm and the AI model that was misfunctioning. And if we look at that today, all the modern, I would say, machine learning software supply chains, that's how they look like, right? So we have the machine learning developer, the data scientist, we have the model source, right? If you're training the model ourselves, if we don't train the model ourselves, we'll have the base models that we're taking from open source, mostly Hugging Face today, and we would be fine-tuning them, right? Or training these models from scratch. Then this model has been built, they stored in model registry, that's why we're storing this huge, terabyte data, and then they've been downloaded by our end servers that's running this amazing NVIDIA hardware, and then they deploy to production and doing inference for customers. And we can see that there is a data sets and models and frameworks that involved in all of these ML ops pipelines, which are usually, in most of the cases, we developers, we're lazy, we don't like to reinvent the wheel. So they've been taken from the open source. And that's exactly where the danger is, right? That's the danger zone. Because if one of these supply chain components is compromised or it has a bug, right? An honest mistake of the open source maintainers, they don't carry any responsibility for this. But because we chosen that, we do carry that, right? And that's very interesting. Now, what kind of problems, right, any organization today has in the area of AI, right, or adoption of AI? Well, nascent MLOps. We don't know yet how to do it properly, right? I mean, we already figured it out with DevOps and DevSecOps for our software builds, and we scanning our solution. We have SCA, software composition analysis. We're doing binary composition analysis. We have great databases of vulnerabilities, CPs, and what's not, right? Pools, advisories of different types, and also many organizations that managing vulnerabilities, but we don't have that for AI yet, right? So that's why I'm saying we're just in the infancy of that processes, right? It's maturing, it's improving, but it's not yet where it should be, right? AI systems, they having really high complexity, right? Because they're super complex. They have layers, they have data models, they have infrastructure which is completely different from our software infrastructure that we got to use, right? And every single piece there of that puzzle comes with its own risks. Now, on top of that, all of our organizations are feeling the pressure. They're feeling this heat of, we need to go fast to the market. We need to rush our solutions. We need to adopt the AI. We need to adopt the agentic AI, which increases the complexity by hundreds of times, right? So basically, we're rushing all of this to the market. We're trying, it solves a big problem because on one hand, it reduces our need for, effort, basically people working, right? Now our APIs are smart. They can think themselves in a way, right? Instead of programming them as we got used until now the AI model handles that and makes all the decisions and then returns to us the results. And in addition, in agentic AI, accessing the data, which is a problem by itself. Now we have also the regulations that looking of, okay, how we can take this under control, how we can contain these risks, right? How we can make the companies do the right things, do the right steps. And eventually, one of the biggest problems is always, training. I mean, it's same as we need to train our employees for not opening phishing emails. We need to train our developers to know how to build secure and resilient AI systems. And add on top of that, a complex supply chain, which not as we got used, a GitHub or a package manager that we can easily use, understand, read, make the right decision of including that thing responsibly based on its provenance and pedigree data. No, I mean, these things are out there and very easy, I would say, usable inside or edible inside to our projects. And also we continuously dealing with models drift and decay, because model, when it gets data that it wasn't trained on, some new type of data, it's getting surprised, right? So there is unexpected results from the models. On the other hand, with all of this complexity in adoption of AI in a proper way, in a mature way, we also have all these risks, right? The vulnerabilities. So we have vulnerable dependencies. And when we're talking about vulnerable dependencies, it's not just the models that we're going to take. It's not just the data sets that we're using these models, right? It's also the frameworks that helping us to train these models. There is a data poisoning, one of probably #1 risk out there, right? Where data can be poisoned and then it can be used to manipulate the model results and produce slightly different outcomes that we plan. Model poisoning, also there. Trojans and backdoors embedded in the model, allowing to run and execute them, drop a file, run and execute it as part of inference, right? Or handling a request. Denial of service attacks, and there were quite few that will take down the model. It means that all our system, right? And we all know the confidentiality, integrity, and availability. I mean, availability will not be there if it's DOS attack. Model inversions attacks, right? Where the adversary is actually trying to extract sensitive data that was used to train a model, right? Because if we train the model with personal PII data, or we train the model example with financial data like credit cards, right? That all of these things are inside the model, they're embedded there. All the strings, they can potentially be extracted if not handled properly. And there is more, of course, right? Like prompt injections that we all familiar, right? Making all these chatbots to basically, we social engineering the AI in a way. And I've seen so many examples where a guy started discussion with a chatbot, and he wrote to chatbot that he's very sensitive about. It was a cybersecurity company, right? So in the name of the company was cybersecurity. And he said to the chatbot that he's very sensitive, is the word of cybersecurity when he sees that, right? So he asked the chatbot not to use that word. And chatbot agreed, so it replaced the word with the letter C. And then he said that C still reminds him cybersecurity, so he really sensitive about that. It makes him feel very bad. So he asked the chatbot to use a bad word instead of the company name. And it used that through all of his chat. And he took a screenshot and pictures and showed how he was able to manipulate or social engineer the chatbot, which is pretty cool. I mean, it's fun, but you can understand where you can take it further, right? Where you can take it further. Let's imagine some example where I'm a company and I'm providing service to my customers, right? So I have like different data sets for my customers, which I'm connecting to this machine learning, and this machine learning makes a query on my behalf using some tools. Now, I'm customer A, can I manipulate that thing to go and get me the data from customer B? Probably yes. So that's kind of the kind of risks that we are facing, and many people would. I'm a very skeptical person, right? When someone tells me, "Hey, there's such thing this is," I'm like, "No way, no, it can be true, right?" But it can be true, right? So like one of the things that how anyone can go into my MLSecOps pipeline and manipulate it and inject there some data or modify my model, right? That's a question. Like, yeah, I don't believe it's possible in my organization because we have MFAs and we have security and we have identities and we have ZTNA and what's not. Okay, let's see. As example, hardware. Is it important? Like what hardware, what framework we are using? Yes, it is. Like look at this one, right? AIBOM importance. So the AIBOM is not just the AIBOM or AISBOM, right? It's also the hardware bill of materials, because we can see that last year NVIDIA patched high severity vulnerability, and you can check it, right? That affects all NVIDIA hardwares, right, with their framework for running models. So they have like their own Linux Jetson distribution. Any hardware it runs on, it's basically vulnerable. And it was, I think, critical or high level vulnerability. Check me on NVIDIA if you don't believe. And this one was well documented, right? So we got the CPEs. I mean, NVIDIA did a great job there. However, this one was even more interesting. So ZenML, it's a very known MLOps platform that's been used by many customers, whether it's in the cloud, whether it's in on-prem. This vulnerability that ZenML published, they did a great job of handling it, right? That says that the issue lies in the API of username or ID activate, REST API endpoint, and existing username along with the new password provided in the request body can be misused to gain unauthorized access. Whoa, someone can access our pipeline of building AI and deploying it in the organization. There you go, live example, 1 year ago. I think it was in August. And guess what? Until this day, there's no mappings to CPs or anything like that on the NVIDIA website. So how are we going to know about that? Interesting. And this is where really AI SBOM comes into power, right? AI SBOM stands for Artificial Intelligence Bill of Materials, and it's a really enabler for AI building and development transparency and security. The good news are that the standards that we all familiar from the SBOMs, because AI SBOM is not different from an SBOM, right? It just has these AI components, and both the CycloneDX and SPDX are already supporting it, right? So you can find the support in CycloneDX, which is about 1.5, and in SPDX, which is about 3.0. Recommended versions of these standards to use are 1.6 and 3.01. And of course, it delivers to us a trust compliance innovation. You can also find some examples we have created for the community. at this GitHub link if you are interested, so you can see what kind of how you build these SBOMs for AI. What's interesting is that we're going to dive a little bit deeper now into what these AI SBOMs are consist of, right? What kind of keys, what kind of data, what kind of metadata we would like to keep, right, or provide. And that's where it really becomes interesting, because it's not like the regular software. You will see it immediately, right? So there's a big difference from the software. So there is the model source, basically, right? That's kind of the architecture on which the model was built. And one great example is Rakuten that was using Mistral Causal LM, and there was some serious issue with this Mistral component, which I'll talk about it. But then, we want to know also modern versioning. I mean, in modern software, we know OpenSSL version 1.1.1 L, right? So we know to identify that there is a clear versions, there is clear release cycles, there is clear adherence to SEMVer, right? For a versioning, and we already got used to understand that, right? We have the major version, we have the minor version, we have the build version. We know how to read that. I mean, it's not existing in the AI world, in the world of the models. There is nothing like that, right? What you will find out is that a model like Rakuten 7B, right? 7B will stand for the general version, right, that they currently maintaining, but this version might have like 20 different commits of that specific model. And each and every commit might be using different data sources, which also don't have any versioning, right? So the only way how you can tie and understand and identify them precisely with these versions is to use the hashes of commit IDs, right? And that's what people do today. Another thing is, which is very important, is model performance metrics, right? And model performance metrics, they really stand for getting, the bias of the model, right? What is the precision of the model? What is how many errors we got? What is the confidence level of every inference, right? So it's very important for us to analyze that same way how we would go and get an open source from NPM, and we would analyze how many downloads it has. Oh, it has millions of downloads. Great. It gives me more confidence, right, to use that specific NPM package. Or I'll check who's behind it. I'll check the provenance data. Yeah, it's not been developed 90% by Russian maintainers. I'm going to use that NPM package. Okay. So I'm doing all of these checks. Same things we need to do. We need to do enough due diligence when we're selecting open source models. Of course, model versions, which is twice here. I don't know why, but I think it's model dependencies in this case, right? Or this is the tools that were used for creating the model itself. Tools like PyTorch, transformers, and others that actually used for operation and working with the model, and also fine-tuning the model. Another topic is model licensing info. It's not enough to understand the model licensing info. We also need to understand what's the licensing of the data sets that were used to train the model, right? Because some data sets might have very sensitive information, again, private information, etc. And we want to know what's the license, who this data belongs, right? We don't want to infringe anyone's intellectual property rights. And in many cases, we don't get this information from the model. In many cases, also, I would say the model creator is not sharing with us the data sources that they have used, right? They consider them as proprietary, they consider them as their IP, even if they're using the open source data sets. And here's, it's our basically responsibility to dig deeper and get all of these answers. So another one is classifications, right? So classification data of these data sets, what kind of data it has, right? It might have like sensitive data, sensitive confidential data, private data, etc., as we mentioned before. Now, the AIBOM has been integrated in the following way with our MLSecOps pipelines, right? So let's look at the bottom side of it, right? So there's the generation of a third-party model that happens by someone else. Then we are using it, we develop it, we train it, we fine-tune it, and then it's been basically recreated in a way when it contains third-party data, but also proprietary data of ours, and then it goes to production after it was fine-tuned, and includes all of this information. Now, how we can generate an AIBOM for third-party AI model? The unfortunate news, and maybe, if anyone knows, please point me to the right direction. There is no generator today which we can point at something, right, and say, hey, I want a AI SBOM to be created for me, right? We have that for source, we have that for binaries, right? But we don't have that for AI solutions. They are complex, they have many moving parts. And some ways of approaching it, right? We can integrate what's so-called Hugging Face API. That's one of the GitHubs for machine learning and AI. We can enrich from metadata. We can do dependency analysis to see what kind of data sets it's relying on. And then we can add some custom fields and output AI SBOM in one of the formats that we mentioned, SPDX or CycloneDX. One of the biggest problems with this approach is that every model has its model card. And guess what? It's basically a free text. So people just go and write there lots of data that they think it's important to share about their model, but it's not structured data. And it's very complex to extract from this free-form data information and map it to the right attributes of these standards. Well, it's definitely very unstructured, very complex problem to solve. And I want to mention that Helen is working on a solution, and she builds these days the AI SBOM generator that she planning to release as an open source. She's going to announce it at the AI SBOM workshop at RSA. So any one of you going to RSA, or if you're not going to RSA, you can also connect over Zoom to the session. We will have a workshop with Daniel, Helen, myself, and there. And one of the announcements that will happen is actually this neat tool that gets you provide to it a URL, and it gets and creates for you the model for AI that you later on can use as part of your big SBOM that you're creating for all of your infrastructure application and the dependencies. So you can scan QR code. If you don't like to scan QR codes, just come to me. I'll give you the link directly for Luma registration. Some of the futuristic supply chain attack examples, right? Drug development, very, very interesting. Exploitation of vulnerable dependency, injecting malicious code into the process, right? And faulty drug predictions, data theft, and operational delays as a result of that. Of course, if you don't have the AIBOM in handy, if we do have AIBOM handy, we know what are the dependencies in our AI, right? We know we have our inventory, right? So we have software transparency. We can patch quickly the software before the harm was done. And we can also continuously monitor our both development and production operational workload operations with checks for integrity and anomaly. And eventually also we always support adherence to regulation by collecting the evidence that we have these things under the control. As part of the CISA Tiger team that defined what is the AIBOM, we actually come to a conclusion that there are 7 use cases that we would like to address first with the effort. And you can, actually the GitHub link isn't correct here, but you can find us online on AIBOM Squad and see all the progress we are doing, including the use cases and the documents. Currently, the document that was produced with the use cases of AI and AI SBOM is undergoing reviews with CISA, and Daniel should be published in a couple of weeks. And eventually, that's our call to action, right? Use SBOMs, AI SBOMs as your foundation. Generate the AI SBOMs for third-party models. Perform risk assessment on these models. There is great new frameworks from OWASP that helping you to make this assessment and analysis. and of course, engage with the AI SBOM CISA Tiger team to continue the great work that's been done. And thank you, everyone. If there's any questions, I'm here, but appreciate you being here with us for this session.
A couple minutes for questions. There's another talk in here that's supposed to start right at 11:30, but.
Hi, Jyoti Wadhwa with NetApp. There was a slide in there that you showed on the different attack vectors. If you can, yeah, keep going. Yeah. This one. So, and even if, go one back. So here, when I look at speed to market, maybe it was one forward. In any case, yeah, it was one, this one. So what I'm seeing is that there's attack vectors that are, you know, related to data, and then there's other ones that are more related to code. And so the remedy for that, or the mitigations that are needed, the controls for that, you know, the ones that are related to data, they need to be treated in a different way from data protection type of strategies. And it would be nice, and if I don't know how they're being differentiated, but I think that's important. I see them always looped together, but in terms of who affects what from an overall cybersecurity perspective and the mitigations. Any thoughts on that from your perspective? Thank you.
It's a great question. And, you know, this is a really, in a way, kind of paradigm shift here about how we're treating these risks, because the data that's been used to train models, right, in a way, that's your, let's call it, that's actually your developer, right, thinking that creates the functionality that you want to achieve. So it's really tied together, right, because manipulating the data can manipulate or result in very serious consequences in the operation of the model, or the operation of the software that wraps the model and provides the, I would say, the responses for the request. Because eventually, you know, like, it's all these models, they are exposed through APIs, right? So there's like software that wrapping these models. There is also, like in agentic AI, there is a software pieces that actually building the tools that the model can use in order to reach out to the outer world, I would say, to the public domain, also to the data sources inside the company, right? And of course, with data sources, we have the traditional problems, right? I mean, someone can, if data is not sanitized or not treated properly, it can, of course, cause a vulnerability and exploitation of vulnerability. But here, the data actually training the model, so it's embedded inside the model, and it can affect the course of, I would say, decision or inference that running through the model and giving the output. I hope it answers the question.
Well, I guess we're done. All right. Thank you.
Thank you, everyone.